Cool. I think we will get started, and then I will disappoint you, and then you will leave. That is the way to finish Commsverse, right? That is the way. So thank you to everybody that you spoke to and have now already left the building. But without these guys here, thank you for helping the organizers be able to put on these events. About me, I'm from the UK, that's why I speak a bit weird. I have been doing the voice Microsoft story stuff from kind of the OCS days, so probably not anywhere near as long as most of the other people that are here and presenting. I authored a MS700 Teams study guide that was probably out of date by the time it was published, but this is the world of dead trees. I also contribute to the Office 365 book for IT pros by Tiny Redmond. If you don't know that, it's quite an interesting concept that there is an edition published every year, but every month there is updates made to that edition of what's changed. If PowerShell modules change, depreciate, something new gets added into the product, they get updated. My remit is chapter 14, which is the Teams devices and calling stuff in there, so hence why that's on here. And as of February, I became a Microsoft MVP, and this is my first time being able to say that in public, so thank you. I will gauge the claps at the end of the session, see how they compare. Okay, so I am here today to talk about location, and location, and location, and a little bit more location. Does anybody want to put their hands up, say any sort of bits of Teams location that you're looking to hear about today in particular, or just the remit, you're bored, your flight's tomorrow, you got some time to kill? Yeah, all right, get out. I mean, so the question for the recording, God help you on the YouTube, is about can you automatically add the latitude and longitude? If you think you've got it bad entering US addresses, they barely work in the US. They do not work at all anywhere else. So my tip and trick, which I will spoil now, is you go on Google Maps, you right-click, you copy to clipboard. That's the only sort of sensible, but it's still not ideal. CSV file it. Well, so Alexander, my colleague from Cloudway here, he was asking earlier in his Hack the Tack for little projects or scripts or bits and pieces, so you two should, have a little word. So, in terms of what I am actually going to talk about, I do have quite a lot of slides. Like I said before, this was kind of, I pegged it as a level 400. I wasn't quite sure where to pitch it. Like, as the joke earlier, it's actually kind of 4 times level 100, right? Because there's a lot of stuff to cover, but I'm hoping by the end of this, you'll have an understanding of just how badly location is implemented across the Teams system. But seriously though, the takeaway should be why you need to start looking at how you map your network, how you lay out your addresses, and where the different interplay of services use those things. I have some slides through the presentation that are kind of tagged as bonus information slides. So that's stuff that's slightly off topic or location adjacent, or if you get the presentation afterwards, is the stuff with kind of extra info or links or bits and pieces. So the slide deck, while it's kind of heavy, is designed to be a little bit more useful post this session as well, right? So in terms of where we're actually going to look at location services, we're going to start with emergency calling. This isn't kind of the deep dive session that Satish had on yesterday, but we will cover a little bit of the same ground. But I've got some stuff that sort of explains a little bit the interplay of how the Teams client checks and what information it looks for and what and where. Where location information is used in call routing for things like local media optimization or location-based routing, why you might use that. A little bit of stuff about location for call quality and why that's important, and because that's a subject that I quite enjoy talking about, there's some bonus slides in there that explain why call quality is something that you should be being concerned with. A little bit on planning, and then I'll be honest, the weak kind of part of this is on the gathering section, because I don't personally know of a particularly good solution to gather this information, put it in one place, and push it out. So if anybody knows one, let me know. And who knows, maybe this time next year we'll be back with some sort of roll your own or Power Automates and Power Platform-based solutions to help deal with these things, because it can be a bit of a challenge. Does that sound good? If it doesn't, I'm afraid the only option is the door at the back. Okay, so location in emergency calling. Why why do we care? I mean, it's more obvious to you guys in the US, right? Because you have very strict regulation around this stuff. But ultimately, we need to make sure that the call, when it is placed, goes to somebody who is able to do something about it, okay? If we're on direct routing, we need to know where we should send that call, because our direct routing infrastructure could be quite broad. We could have many different gateways with many different breakouts. We need to know if we're placing the call to a different location for an emergency call versus something different. And do we need to do anything else when that call is placed? And this is where there's now policies in to notify, to conference people in, that kind of stuff. This is why location is important, because it will vary based on where the user is when they place that kind of a call. So how this works is there's kind of a three-step process. The first one of these is the trusted IP address, right? That's what it's called in TAC. And this is what Teams uses for quite a lot of these location things to determine if you are on a corporately managed network. And what it does is, you know, when you connect out to Teams, the Teams service looks at the IP address that it sees you coming from, the public IP address, the reflected IP. I'm looking at you. Is that the right? Reflexive. There we go. See, get off your phone. It looks at that public IP address, and if that doesn't match one that's configured in your tenant, it goes, yeah, you're probably not on a corporate location, or you're not on a corporate location. So it doesn't bother processing the rest of these things. So it doesn't matter if you've done the Wi-Fi access point mapping, any of that jazz, the subnets, anything else. If the trusted IP, the public IP doesn't match, it doesn't try anything else, okay? Second thing is referred to as LIS, Location Information Services. So it's like, well, if you are internal, where do I now think you are, okay? And this is the address services. This is where in your tenant you have an address registered, and it is LIS that is doing the mapping of that. And then lastly, we have network settings. So network settings is another set of some of the same information that we had for LIS, or have for LIS, but it has some other kind of policy information and configuration attached to it. So LIS is purely about what is the actual address that I am mapping to, and network settings is what policies are applied because I'm in a particular location. So here's your first bonus slide. So this is relating to calling plans. So this is, if you are in the States and you have a dynamic location lookup that is successful, it goes to the PSAP for that address that has been looked up. If you're not at a dynamic address, then you go to a clearinghouse, an ECRC, which is an emergency call relay center, he says reading off the notes, and they will validate the location with you to make sure it goes to the appropriate PSAP for the location that you say you're at. And you can test this by dialing 933, which is, you know, a handy way of checking that everything's okay and wired up right. If you're in the UK, Ireland, and Canada, calls will go to an ECRC to determine before being passed through to the handler. That's because we don't have the same sort of dynamic location pass-through and expectations and that kind of stuff, so it happens differently. Australia, Japan, other calling plans, you can see what kind of happens there. So like the basic ones down at the bottom here, calls just go to the static location that went to the number. So that's where if you provision numbers through TAC, you either, depending on where the numbers, which country they're for, have to associate an address at the time of provisioning, or you have to associate an address at the time of allocation to a user, and that is what's referred to as the static address, right? So that's kind of the fallback. If we don't know where else you are, that's our address of last resort. So the trusted IP address, it is shared with other location lookups, and this is where if I hop over here, we can find it under in TAC, network topology, and trusted IP addresses. And then hit add, and you get the little pop out here. We can pick it's an IPv4 or a v6. We can specify the IP address. We specify the range that is associated with it. We can add a description, and we hit apply, and that puts it in. So it's very, very simple to put in there. But, you know, just do need to be a little bit careful here that because of that, this is the first gate. This is the first hurdle. Don't just put what your default, you know, natted address would be. Just kind of make sure you put your ranges of your public IPs, because then if something else isn't configured right and someone appears from a different location for some reason, at least that will catch them if it's like, hey, these are just the public subnets that our company owns. We've added them in there. Okay. Again, on some of the slides, you will see I've put the little PowerShell commandlets. So verb as in get, set, add, remove, grant, and then whatever it is that we are dealing with. And then kind of I've got what the main components would be to, to fill those commandlets in. Okay, so that is the trusted IP address portion. Next up is LIS. So LIS comprises of kind of two location type bits of information. We've got the thing called a civic address and a thing called a location. And annoyingly, the naming is different between TAC and PowerShell. So civic address is an address in TAC, and a location is a place in TAC, okay? And the thing that feeds into them are these bits of information across the bottom. So we've got the Wi-Fi access point that the client is connected to, the switch port that the client is connected to, or the network switch or the network subnet that we are connected to. And the address, there is a hierarchy for these. I don't know if I've got it on this slide or if it's on one of my later ones. But effectively, if I remember off the top of my head, it will take the access point information first, and if that matches, that's what it will match against. Then it's the switch port, then it's the switch, then it's the subnet. So the subnet is kind of your catch-all of last resort again from a LIS point of view. The switch information comes from LLDP if you have that available, and there are, if you look on docs.microsoft, the requirements for what versions of the Windows client, and Windows OS and Mac OS clients, and OS X version that is able to do that lookup on behalf of the client. And the Wi-Fi information is the BSSID, so it's kind of the combination of the MAC address and the SSID that's being broadcast, and that is the client will look at that information of the network that it is connected to. It's also worth kind of mentioning that here, the client will do this kind of refresh periodically, so it will relook up the address when it detects that its network settings have changed. So if it detects it's on a new IP or something has changed, it's swapped from Ethernet to wired, to wireless even, it will relook up its location to see where it's at. Okay, so adding an address. Let's go back to Edge. So this time, we want to go to locations and emergency addresses. Here, you will see the addresses that you have already had configured in your tenant. And once they have been validated, you aren't able to edit an address. You would need to add a new address, reassociate anybody who was associated with the old address to the new one, and then be able to delete the old one. So kind of misleading that you've got an edit button there. It won't let you do it. Up here, you would give this a name. So what was the name of the gas station? No, I'm kidding. I'm doing the castle. I'm doing Bamborough Castle. Anybody watch The Last Kingdom on Netflix? Viking, UK, yeah. Set at Bamborough. Bamborough Castle is where I got married, so I use Bamborough Castle for locations and things. That is in the UK, United Kingdom. Here you were asking, is there a way of easily inputting it? In an ideal world, I would fill my address in and it would go through an autocomplete like you get on shopping carts and all that sort of stuff. Fill it in. Most of the time you have to do it manually. And your question before was about the latitude and longitude. Just to show everybody else, the quick tip that I use for that is from your mapping program of choice. Generally, when you right-click on the map, you can copy the latitude and longitude into your clipboard, and then you can come in here and paste it, but it's a bit of a pain in the ass because it's too long, you've got to move it to the other things. If you use Bing Maps, I think it doesn't give you it quite as accurate, a nice comment on Bing and accuracy. Down here, you've then got the organizational name, and you also have the ability to put an ELIN in there. ELIN is kind of the old school technology for doing emergency outbound dialing. So effectively, if you have the right application on the right sort of SBCs, what used to happen, and you could still do it if you wanted to, is that when you place an emergency call, it kind of masks the number with a particular pot of DIDs or DDIs. DIDs is the right one for you guys? Yeah? Okay. DIDs. They're DDIs to me. But it means that for a period, if there is a call comes back in on that number, the SBC has a record of which number it was that dialed it and routes it back to the original person, so that if the emergency responders need to dial back, it goes back to the original person. That's the stuff that's kind of sort of superseded now with dynamic E911 and sort of more dynamic fluid lookups. I haven't finished what I was going to show you. So once we have our address, if we go into our address, you can see here, this is the emergency address and the location. We have at the top here that there are 0 places associated with this. That's the locations from the PowerShell bit. Here, we can click to add a more specific location under this bracket of an address. So this could be, if the address is for a campus, this could be particular buildings in that campus. If this is for a high-rise building, it could be for particular floors or sub-locations inside that building. And this is where, I think your laws are that you should be as granular as is reasonably possible. Satish nodding at the back there, so I think that's right. But it's going to depend to what level you want to take it. Generally, the more detail, the better, but then you've got more work to do to make sure that A, you gather the right information in the first place, and B, to maintain it. And the crucial thing with the emergency service stuff in particular is making sure you maintain it so that it is correct for the one time that somebody really, really needs to use it, right? But the places, if I add a place in here, so, I don't know, this is my house, so my bedroom, right? I don't know, might have a phone in my bedroom. If we click on that and go into it, again, we can see here, we've not got the places because we're already one layer down, so we've got Graithwaite in my bedroom. How many users we have associated with this particular location, and how many numbers we have associated with it. But then down the bottom here, we've got those other bits of information that I was talking about, right? It's the ability to add a subnet. So here we can add a subnet, either an IPv4 or a v6, subnet mask. In fact, I don't think it does have the subnet mask, is it? It's just the flat subnet. And then the location that we're associating it with, or the Wi-Fi access point, hit add. We can enter in the BSSID, et cetera, you get the idea. But the kind of crucial thing is that we can do it at that lower level, or we can do it at this level here at the top, right? So you can choose which way you want to put them in. Any questions, comments about that? Good stuff. Okay, PowerShell, those are your commandlets that you would need to use to modify and deal with these things. Again, these are available, post if you want to have them. All good? So that's trusted IP, that's LIS. Next one is network settings. And this is the kind of policy type stuff of how and where should we now deal with this call that it's been placed. You're right there, Alexander, keeping you up. Thanks. Network settings are broken into 3 bits of information. We have a region, we have a site, and then we have a subnet. So we don't have the granularity that we did when we're talking about lists, but we only care about lists for the address, okay? This subnet stuff is people in this subnet have effectively this policy or these policies or this configuration applied against them. This one is shared with some of the other services. And the hierarchy goes that we have the region with a site with a subnet. Okay, so you belong to a subnet, therefore you belong to a site, therefore you belong to a region. It is, in this instance for emergency calling, used to assign a calling policy and also a call routing policy. You can have these things applied to the site. If you have a user policy will override the site policy. No, that's the other way around, sorry. A site policy will take preference over the user policy because that covers the scenario where a user has traveled to a different site. So we are in this location, therefore this is the way we want these things to behave versus when the user's in a location that doesn't have something defined, we obey whatever it is that's configured against the user. So this stuff over here is under network topology, and instead of jumping to trusted IPs, we stick with the default one of network sites. If we click on that, we can see here that we have, well, first of all, our subnet that's defined. This time we do have a range. So if I hit add, you can see we've got the v4 or v6, and then the 0 to 32 for the subnet mask. Give it a description if you want to. And here we have the emergency calling policy and the emergency call routing policy that's associated with when a user is matching those subnets. This is what we want to do. So up here, under emergency policies, this is where we can manage those 2 things. So the call routing policy is something that applies when we're dealing with direct routing. We have a user configured for direct routing. If it's operator connect or calling plans, we've already talked about how calling plans handles what happens when you place an emergency call. On the operator connect side, you need to talk to whoever the operator connect carrier is. They might have a relationship with the bandwidth or a few of these other like dedicated specific emergency policies companies that they're hooked in with. If I hit add here, you can see we have the ability to do dynamic emergency calling, and we also have the ability here to specify what the emergency number looks like and what the mask for that number would be. So this is where, again, for direct routing, is you might want to say that 112 or 999 translates to 9111 in this scenario. So you're kind of covering your bases. And the other important thing to remember or note is that when Teams sends this out, it doesn't send it with the plus to the SBC. So you need to make sure on your direct routing SBCs that you are catching that number coming to it without a plus on the front and that you appropriately route that. And this is part of the whole end-to-end testing that you should be doing as part of a deployment anyway. Okay? For the calling policy itself, if we go and add a new one, we can give it a name, give it a description. This is the notifications that we have. So this is the functionality of, we know somebody has placed an emergency call, what do we want to do? We can send a notification, we can conference someone in, but they're muted. But again, as has been pointed out in the other sessions, be aware that someone can't take themselves off mute if they're conferenced into that emergency call. So it will only be the responder, the person who made the call, and then facilities or whoever you choose will be able to listen in, but they can't take themselves off mute to then participate in the call. Or they are allowed to be, to contribute with unmute there. Users and groups, who do you want to actually include in that notification that goes through? The bit that's kind of interesting here is you've got this tick box for if you want to allow external location lookup to occur as well. So this could be a scenario where you have users who have VPN'd in, right? So think back to that hierarchy of what we're doing. We're matching a trusted IP because we're VPN'd. VPN with Teams, bad, naughty, no, but you might be doing it. So you appear as though you're coming from a company location. You might match one of the subnets in lists, and therefore you've got an emergency address location. But we also maybe want to come in here and say, actually, this subnet, which is the VPN subnet, we want to turn this on and say that we are allowed to do external location lookup. So the Teams client can then still look to its local surroundings of, talk to the OS or what Wi-Fi access point am I connected to, what's nearby, what do I know about where I am, or allow the user to manually override and enter their own address so that if they place an emergency call, it's not popping up from the company location, it's coming from where they are actually based. Okay, so that's quite an important toggle to make sure you cover maybe like VDI subnets or VPN subnets or something like that you would put a policy to include those, okay? Because Teams would see it coming from, but it depends to what level you're split tunneling. It would need to be the whole Teams services connecting, because you could, in theory, split tunnel just your media, yeah. Okay, 36 minutes, we're doing good, we're doing good. 36 more? Yeah. Look, we've done one box, all right? One box. Call routing. Why do we need to have call routing location? Why do we care where you are for call routing? Again, relatively self-explanatory, but the two main scenarios are for local media optimization, where we want to make sure we are sending traffic from the user to the gateway, SBC, on the best possible path, because Teams doesn't like going the long way around if you can help it. Or location-based routing, or kind of toll bypass. There might be legal reasons why we have to enforce that a call goes to a particular gateway or breaks out in a particular country or a particular part of the world. So the other thing we can do is also network roaming policy, where we can kind of quash down the bandwidth that is used from a site, from the Teams client. If we have a location with a piece of string internet connection, we can say that you're not allowed to use video when you're in that location, etc. What was that called in Scope for Business? It's gone from the top of my head. Where you could set the restrictions on the amount of bandwidth. Basically, the CAC, that was it. CAC was nasty because CAC just was like, nah, failed, your call's not working, you didn't get a nice error message or anything like that. This is kind of a nicer way of doing that, where it means the Teams client will kind of dynamically either not do video, or it will like restrict down the amount of bandwidth that it's using for the call. So, media bypass. How many people are familiar with media bypass in Teams? Okay. So for those that weren't, the problem when direct routing first came out as media used to have to go from the user up to the cloud to be processed, to go back down to the SBC, to then break out to the PSTN. The first version of the solution to this was called media bypass, where you could hairpin the traffic on the firewall. It would turn it around. And the way that worked was that the public IP address of the SBC was given out as part of the candidate negotiation. The problem is that you've still got this firewall having to be involved in this real-time media traffic that's having to turn that around. So it's having to accept an internal request to a public IP address that it owns on a different interface. So sometimes that can be a bit of a configuration challenge for the network team, for the firewall people, but also you've got the firewalls now having to do whatever inspection or allow or passing through, or you've got another hop in there that you don't necessarily want. So local media optimization is the solution to that. That allows you to now directly say, even though we're setting up the call and we're signaling out to the internet, now we want this client to talk directly to the internal IP address of the SBC, and we've cut out all of that nonsense. But, sounds great, it is still a little bit complicated to set up because you still need to do the network mapping and have the subnets and figure out what's where, right? The other reason that you might do it is if you have multiple SBCs, so potentially here we've got two, where we have one SBC that's configured for Teams for direct routing, and we have a second downstream SBC that maybe we don't want to go through having a certificate on. We don't want to give it a public IP. We don't want to deal with actually putting it out on the internet for Teams to talk to. But with local media optimization, we can still have the IP address of that SBC included in the media negotiation setup so that my client will send media directly to that SBC to kind of smooth the process over a little bit. Okay, clear as mud? Cool, great. How do we do this? Well, we use a trusted IP address to figure out that we are inside the network. We've already talked about how we can set that up and what you need to do. We need to use network settings to look at, what site is the user associated with. And then next, we need to configure the voice routes so that we know which SBC we're going to talk to. And we also need to configure the SBC so that it has a site that will match the site that the user is. And again, there's configuration options there, so you can kind of make it always do bypass or always, do LMO or not, or et cetera, et cetera. Sorry, direct media. Yeah, thank you.
Does this also work if your SBC is cloud-based, so like an Azure hosted SBC?
Well, if the SBC is cloud-based, yes and no. You've got to look at what the best traffic path for you is going to be. If you don't have any of this on, your traffic path is going to be you to the Teams media processor to wherever that SBC is hosted. It might be that that's actually quite an efficient path because you've done the work internally, haven't you, all of you, to make sure that you've got the best possible internet connection out to Teams, and maybe you've not done any optimization work to wherever that SBC is hosted. But if that SBC is on the end of an Azure Express route or something, then maybe, you do want to kind of keep that inside your perimeter. So yes, you could do it, but you would need to look at your design choice. And also, it's like back here, you've also got a decision when you're doing media bypass or LMO, what happens to your external users, right? So here on my diagram, I've shown that, hey, we're going and talking to our edge firewall, and that's passing it through to the SBC. Reality is you probably don't want to do that. You probably just want to say, screw you, you got to go to the team service. The team service comes in because, again, we've done all that work to harden and make sure things are set right. Did that not answer your question? Okay. Let's just put all of this up on the screen. This is one of those bonus information-y bits. This isn't technically to do with location, but it's kind of fun to talk about, and I'm quite proud of those diagrams that I did way back when. But this is how you do voice routing. This is when we have SBCs for direct routing, how we send a call to it, okay? So the voice routing policy contains the PSTN usages, and they're handled in order. the PSTN usages link the voice routing policy and the voice reads together, and the voice reads is the thing that contains a regex pattern that says if the user has dialed a number that looks like this, send it to this SBC is allowed to process it, right? So you can have a really basic version of this, which is a voice route with .star inside a PSTN usage, inside a voice routing policy, and you assign that to your users. So your users have one voice routing policy associated with them, or maybe you need to do some clever stuff and say, if a number looks like this, we want to send it to this SBC, and if that one's not available, send it to there, and they fail over, if that's not available, it will use that one, etc. You can build these things up. So that's what the voice reading side looks like. So it's important that, back when we were talking about our emergency voice reading policies, that's kind of similar thing that we're saying when a user dials an emergency number, these are the gateways that we are going to send it to. LMO SBC configuration. So, shall I do this live? Let's have a look at it. Down here, this time we want to go to voice, it's hiding under direct routing, and then we find our SBC, we go into our SBC, we get all these lovely statistics, then we go to settings, then we go to edit the SBC because we want to change the settings, and here we get the page that you would have if you were setting up a new SBC. So there's all the other configuration stuff in here about, PSert identity and response codes and all that fun stuff, but down the bottom here are the ones that we're interested in for a location point of view. So that one's the toggle for basic media bypass if we want to have that. Then down here we have location-based routing, and we have the ability to associate the site ID. So the sites that we created in some of the earlier steps, we could come in here, we can fit in the drop-down that it's against this. We do want to do media bypass, and then we've got some choices here for what bypass mode we are in. Only for local users means that we will only talk to the local IP address of the gateway when both the user and the SBC are in the same site. If we're saying always, then we are always going to get given the internal IP of the gateway and go talk to it, right? Okay, location-based routing. So back in the day, there used to be the notion of doing least cost routing, right? You would try and keep the call on your IP network for as long as possible. So if we had a European user making a call to the States, we would do that over the internet, and then we would break out, and we would only be paying for this short hop of the call so that we're paying the least amount of money because it's effectively a local call. Location-based routing is actually generally used for the opposite scenario, which you could call most cost routing, but it is where there might be regulatory requirements or legal reasons where actually if we have a user over here, they need to break that call out to the US with their local carrier, with whoever the telco is in that particular region, and then the long haul has to go over the PSTN network and you pay the full price for doing that. So with location-based routing, to configure that, we assign in the user calling policy under voice routing, there's this button in that policy that says prevent toll bypass and send the calls through the PSTN. So that's like when they're making a call, we need to make sure that it's going out over the PSTN network as opposed to being as a Teams call. In the site, remember the sites that we configured where we had our emergency calling and our call routing policy, there's a little toggle box here for enabling location-based routing. We need to turn that on, so we're saying that this site, this subnet, effectively has LBR enabled for it. And then on the gateway, we need to enable location-based routing, and we need to, in fact, that's what my overrides were for. I said that in the wrong order. Was it something I said? Was it just that little mistake? Yeah, so we then need to configure it. Override, the override setting here, which is this one, LBR user override, that is if a user is external from the organization, so we're not inside, we're not matching the trusted, we're not matching a site, do we still want to allow a user to be able to talk to this SBC? You know, in some cases you might want to, some cases you don't. It's going to be very use case specific. Another little bonus slide here. What if we have more than one client? That's the whole point in Teams. We can be signed into more than one location. It is determined by each endpoint. So if you've got a phone at home that you're signed in with and you're on your laptop and you're traveling, if you make the call from the laptop, it depends on what the configuration for the site that the laptop is in, as opposed to looking at everything as a whole. What's used to decide if the call is okay? Is the user have the LBR policy configured for them? Is the endpoint in a site that is covered by LBR? And then is the SBC that the voice routes are pointing to covered by LBR as well? That's kind of the three things that go through. Teams is great for letting you have flexibility with your calling. What happens if we're doing transfers, forwarding, conferencing? Transfers, routing of the transferring user is applied first, and then the policy of whoever the recipient is to determine which SBCs it needs to talk to in what particular order. Conferencing and group calls, it looks at if one of the participants has LBR configured. If the call can't complete, you get a message in the client there. And inbound calls will obey the unanswered call settings. In Teams, you specify if we're going to forward to somewhere else or if we're going to go to voicemail, etc. So that's, because Teams voice is complicated with so many different scenarios of where people can be and what config they've got, that's kind of a handy little cheat sheet for what will work in what scenario. Okay, nearly there, he said, being on box 2 of 5. Another little bonus slide. This isn't really a location thing in Teams, but it is worth noting that the usage location attribute affects a couple of things to do with Teams. First one is you have a dial plan, right? So when you type numbers in, Microsoft has a dial plan that translates what you've written into E164, and you can have a custom tenant dial plan, but there are default dial plans for all the different countries available. That is determined from the usage location, it's 2-letter ISO code. It also dictates the service availability, right? So, for me as a consultant, I spin up the CIEs, the customer immersion environments, where it's like a little demo thing, and I want to do calling, and it's great, and I'm going to talk to a US customer, so I'm going to get some US numbers. I can't then assign them to my users because my users were created in Amsterdam, and they've got the country usage location is set to the Netherlands. So you have to go and flick that, and then I can associate a US number with the user, right? So just be aware, usage location attribute, make sure you're synchronizing the right thing from your Prem AD if it's coming from Prem AD, and if it's from online, make sure it just matches the location country that the user is in, right? It's common sense, but it kind of can trip you up in a few situations. Alrighty. Roaming policies, I talked a little bit about this, or just kind of show the screenshots. This is the same place under network topology. This is an old TAC screenshot for those that are keeping track. But up here, we've got the network roaming policy. If I create one of these, fairly straightforward, do I want to allow video or not? If I'm allowing video, what bitrate am I allowed to use for the video connection? Okay. PowerShell is there. Call quality. Call quality. Why do we care about location and call quality? First of all, we care about it in 2 locations. One is in CQD and one is in call analytics. CQD is the top-down tool for looking at the quality across your deployment. And ACD, call diagnostics, is the bottom-up. So call quality is show me everything CQD is the show me everything that's happening in my tenant, and we can try and figure out the trends and everything. ACD is this user had a problem, and we can go and look at what problem that user had and why they had that problem. Why is location kind of important in Teams? It's important because there are so many different places that a user can be making a call from, and stuff that might work really well in the office, might not work that well on hotel Wi-Fi or in Starbucks or something like that. So there's just so many kind of pieces that you need to consider to make sure that you're doing what you can to have a good call quality. This is what I meant that I've got sort of some bonus material in here. This is just extra bits and pieces. But this is a diagram I've used when I'm trying to explain to a customer why they are having a high level of issues with calls, right? So if we have a user in an office location, I can control the endpoint that they're on. I can control the headset that they're using. I can sort of control the access point or the Wi-Fi. If someone turns a microwave on, you're still going to have problems, but you can have a little bit of control with it. We can control the network. We can control the internet connection. we can sort of control the breakout. If we've got a user from home, we can still potentially control the headset, maybe. We can sort of, in theory, control what's configured on the laptop. We can control how it's talking to the internet, but we can't control the user's home Wi-Fi or home network in the same way that we can. That's why it can be a challenge, because there's so many different bits that have to kind of stack up to make a good experience, which is why we then have this slide that I stick in here. This was something that I've nicked and modified from a Link Conference 2014 deck, was I think the first time I saw it. It was Microsoft material, but it's part of that setting expectations with users that depending on what type of a meeting or a call you're going to do, if you're doing a presentation to your board, probably don't do it when you're in a hotel lobby, right? You want to be on the best possible experience with company headset, company computer, company Wi-Fi, wired in, connection, all that sort of stuff. So this all kind of helps. Why am I talking about this in the location? It's because inside CQD, you can upload building data. And it is helpful in CQD when you are looking at the trends. Again, slightly old screenshot. These days, you would probably be looking at Power BI reports, because the Power BI reports have sort of superseded and taken over from the QoE or CQD-based reports. But it is really important when you're looking at these trends to be able to differentiate between a user who was at home doing whatever they wanted versus a user who is in your company office set up in the best possible way that you want them to be set up. So having location information in CQD allows you to look at the trends across those two different scenarios. Incidentally, when you are in CQD, another little bonus bit, if you're doing any filters in Power BI or in QoE or anything like that, you will see a whole bunch of primary and secondary for the same bit of information. Does anybody know why that is? So it'll say like secondary client IP or primary client IP or secondary audio device primary. Anyone know? Yeah, so it's primary is always the server side, and in Teams, the server side is always Microsoft's. It's never yours because you don't run Teams yourself. So that's why when you're filtering and dealing with stuff, it's always the secondary attribute that you want to be looking at. Okay. So what you do for CQD, this is the kind of information that you would want to be filling in. You can see the type of data, whether it's optional or recommended or mandatory, and then how you would fill it in. The trick with the CQD is it can either be a TSV or a CSV, but you don't put column headers in the file, right? So you can do that when you're building it, you can do it in Excel as you're creating it, but when you take the file and you upload it into CQD, you strip the headers out. There was a chap asked me a question, sorry, that's very British, there was a chap. A fellow Jollywot asked me a question in one of the earlier sessions about can you extract the data? Because actually the CQD is, you use the same file inside reporting labels in TAC. Reporting labels is where it goes into ACD, and inside CQD is the building data upload file. That's where you put it. You can't get the file out of reporting labels, but if you have a file that you put in CQD previously, go into CQD, go into a tenant data, and you will see the file that you can download. You can also time box the files in CQD, which is kind of interesting. So if you're really organized and on it, and you know you've got some network work being planned, you can pre-populate CQD with the changes that are going to be made, and you can put a date start from when that new building data file will kick in. Okay, but you got some kind of fun stuff here that also help, like, it's inside Corp, whether the connection is using Express. Seriously? Seriously, 15 minutes.
I've got a party to go to, leaving at 4:15. As much of a party as this is,
it's a good job you're not going to Comsverse. VPN, that's another important one, right? So when you're looking in CQD, some of the core things to look at are we on a managed location? Are we on Wi-Fi? Because Wi-Fi is the other big kind of issue. But is the user, or the site on VPN? If you've got users connecting to Teams through site VPNs, again, it's back to that, look at your basic network 101, and ideally you want to be doing split tunneling and avoiding that. Anywho, CQD endpoint mapping. Another little bonus slide here, not related to location, but You can upload an endpoint map to CQD as well. That can help with your device stuff. That's why he's left, because this is about devices now, right? And I put Logitech on. Maybe that's it. There we go. It's all making sense now. But here, this kind of helps with figuring out particular tags that you can then use to filter on types of devices in your organization, or if you've got a bigger state of MTRs deployed, the endpoint mapping file can help with that. Information about it. Okay, call analytics, same file as that you use for CQD, except in TAC you put it under reporting labels. So if you've done CQD, just go and put it in reporting labels as well. Planning, nearly there, planning. I promise that these ones are going quicker. Network planner. The network planner, does anybody use that in TAC? Has anybody played with it? Handful of people. The others not using it because it's not valuable or because you don't know about it? Yeah, so. So the planner in theory is used to help you plan your network capacity, right? The good old days we used to have spreadsheets and this user was doing this many calls and a call was this amount of kilobits per second, and therefore, if we had 80% concurrency, it would be this, that, and the other. That got really hard, and it stayed really hard with Teams because you've got people doing all sorts of stuff all over the place in all sorts of different locations. But there is a tool in TAC that will help kind of with the setup and processing of a form of rudimentary network planning. In reality, what you would probably do is if you had a big migration coming up or a big expansion of your Teams deployment, go and set some stuff in Network Planner. It'll give you a rough idea of what things look like. But for the love of everything, make sure you have CQD set up and make sure while you're doing that migration, you are looking at CQD, and at least once a week, maybe every 2 weeks, certainly once a month for the duration of your project and beyond, look at the trends in CQD to see what is happening for those subnets, those locations that you're migrating, and as an environment as a whole. Like I was doing, this was back when it was Skype for Business Online, working with a customer, and on the weekly project calls, we would do that. I just had a stock report that we went and got. It will be much easier now with Power BI connectors. Boom, into the project report, this is what's happening. We saw a spike in one location. Stuff had gone really, really bad. We were suddenly getting like 30, 40% poor call quality. Incidentally, as a guideline, 4% is what I personally would say is an acceptable level of poor quality calls. Back to that point earlier of you can't guarantee every scenario all of the time. So 4% is what you would kind of be shooting for. We were seeing 30, 40%. Turns out what had happened is the customer, the networking team was in the middle of doing a big WAN migration, and they were moving sites from the old SD-WAN to the new SD-WAN. So suddenly 2 locations that were talking to each other used to be on the same, provider network were having to go out over the internet and back in. So from those project calls, we saw that they could go talk to IT, they could send an email to the location and say, hey, look, we know for 2 to 3 weeks this is going to be a bad experience, but this is why, and in 3 weeks, this, worst case, this should clear up because you're then going to be migrated and we'll be back on the same platform. So that's why, the real world, how you would roughly approach it. The way Network Planner works is it's based on user personas. So a persona is, if we have a user doing a particular type of calling, we build up a site and we say the site has this amount of bandwidth and it has these user personas associated with it, and then you can model, therefore, roughly this might be the amount of bandwidth that we would specify. And the personas, the important thing is whether they are going to be doing audio, whether they're going to be doing video, and whether they're going to be doing desktop share. And there's a separate persona for MTRs as well, because an MTR, you're expecting that to be all guns blazing, all bandwidth hogging, as much as it can be, because it's a video first experience, right? But don't get hung up on, how much video or how much voice. It's do they do voice, do they do video, and that's what your persona would be based around. This doesn't in any way impact the actual configuration. So those network roaming policies are what you want to do if you do want to apply different configuration for limiting video in some scenarios. The only way that you can configure the network planning tool is in TAC. Alexander, yeah? This is a little, overview of what that would look like. So you can see, I've got my sites flagged red because it's going to go over, et cetera, et cetera. The reason I am looking at Alexander there is because Alexander has written a tool on his blog that you can go and have a look at. if you're in his hack the tack session earlier, it shows a way that even though this isn't surfaced through PowerShell or anything like that, you can go and kind of capture a token from your browser, chuck it into a script. The script can go and read the CSV, and it can, populate this information for you. In Alexander's session, that applies to a whole bunch of other stuff across TAC, so like phone bulk policies and, well, what was the other stuff you covered? Stuff and things.
It's kind of like a extended version of the CQD template.
Yeah. Yeah, so you start with the CQD, you add extra information on the end, and then you can shoehorn that in. So again, doing a big network upgrade, Planner's quite an onerous thing to do. That can simplify it for you because you've already got your CQD building data, don't you? You can just add the extra information into it and shut it up in there. Okay. Gathering the information. Where do you get this stuff? This is what I meant at the beginning of I don't have a neat answer necessarily for this, Satish. I think, did you say something that you guys had some sort of a product or a solution that would help with pulling some of this stuff together?
Absolutely. So every network would be a bit different. Someone could be using Cisco, someone could be using SonicWall, someone could be using Jellyfy network. So every network is different. So automations are built based on the requirements. So yes, we do have some things around this.
Yeah, so the answer for the recording is yes. Go find Satish from the speaker list. He will help you with bits and pieces. But it's a challenge, right? Because some of that information is your networking team. Some of that information is in the firewall. Some of that information is in the switches, the Wi-Fi access points. That's what your networking team. But facilities should be the ones that then have the actual, what the official addresses would be that you need to upload. So you need to kind of talk to both of them. And, again, there might be some tools, some config that you can pull out and get it for. But then what do you do when you've got that data? Again, I don't have a nice answer for you. People will chuck that into Excel. People will chuck that into SharePoint lists or SharePoint document libraries potentially. I did have this grand vision of well, maybe actually you could start creating this giant repository using Dataverse for Teams, and then you can do some scripts and it'll fire it out. And it just got partway through and you had so many different nuances of what information you have for what particular thing that it kind of doesn't become feasible. Maybe this time next year, whenever we do this again, I might have some way, or Satish might have, taken over the world with their version of this. But this list down the right-hand side, that's kind of my, basic starting point for what sort of information you should be looking at to then narrow it down to populate these tools. So, site name, network mask, the public IPs, remember that important trusted IP one. The physical locations, that's kind of the stuff for the emergency address. Number of users, meeting rooms, that's more to help with the CQD and the network planner kind of things. So that's kind of, the rough, if you were starting somewhere, that's a big list, but that's still roughly where I would start with it, right? So to get us over the finish line, main takeaways are going to be, hopefully you can see the location is kind of important. Hopefully that's helped point you in the right direction for a few different places where you might want to do this. Hopefully you can see if you're doing direct routing, you don't need to worry about some of that location, but you still do need to worry about it for other bits and pieces. That external IP is kind of the key one in there. Get started with your CQD data, store it somewhere. At least if you've got it somewhere, you can start working on it and updating it. But that's kind of the important thing here. It's all very well that you do this one time, you go get everything, but you need to then stay on top of it. And in a previous version of this presentation that I did, I had kind of a thing that as we went through, it was like each of the different buckets we were gathering, we were putting that into this list. This was the big old list of everything that essentially to do with the location, that you might need across different areas of TAC and Teams. Roughly, again, this is one for the books for later on, but this is kind of where the different things are used and where you need to store them back into TAC as a recap table. Any questions, comments, thoughts? I'll just pop that up there. That's kind of your further reading, your homework for anybody that wants to dive into these things. Any questions, any comments, any thoughts? Because if not, I'm done and you're done. And that was comms verse.